That means perfectly black. So suppose there are certain number of pixels and I mark here. Let's say there are 1000 pixels which are, for example, at 0 intensity. Then let us say there are 500 pixels which are at intensity value 1. And let us say so on and so forth. Let us say these are 750 which are at intensity level 2. So I find out how many pixels exist at each intensity level, right? And this I find out for all the 256 intensity values. Now this particular graph, this is called histogram of the image. This is called histogram of image. Are you getting me? Histogram of an image, of this image. Right? That means it's a plot of number of pixels of the image, how many numbers are there at each intensity level. Now, if we divide, let us say this image is having a size m pixel this side and n pixels this side. If I divide this number of pixels by m and multiplied by n, so that means now it is number of pixels by total pixels. So the shape of the graph will remain same. Only thing is that every value will get divided by m cross n. That's all. Nothing else will happen. Shape of this graph will remain same. Whether you call it graph or whether you call it a plot or whether you call it, that will remain same. Only thing is that the values on the y-axis, they will change. For example, if let us say it is a 512, this is 512. So that means these were the values. This was 1000. This was 1000, and this was, let us say, m into n, as I told you, is 512. So this value will become 1000 divided by 512 into 512. This will become 500 divided by 512, 512. That's all, and so on. Then it is called, if I divide by m cross n, and then whatever is the this figure, that is called probability values. So that is called probability density function. Probability is defined as number of pixels divided by number of pixels at a particular intensity level, number of pixels at intensity I, let us say intensity value I, divided by m by n. That is the probability associated with ith intensity. Probability associated with ith intensity level will be number of pixels which are lying at intensity level I divided by m cross n. So that will be proportional to this. So now you understand what is histogram. Sometimes this probability density function is also called normalized histogram. Normalized. Most of the pixels are near intensity level 0. You can see the histogram of this image. That histogram may only intensities from here to here, they are visible, and there are no pixels beyond this. इससे आगे का इंटेंसिटी जो है, ये वाला पोर्शन जो है, यहां से यहां तक, इसमें कोई पिक्सल नहीं है. सारे के सारे पिक्सेल्स जो हैं वो यहां हैं. है कि नहीं? Similarly, if you have this second image which is quite bright, so that means most of the pixels are near white level. So as you can see that this is the histogram now. The low contrast image, this is the low contrast image. Then the fourth one, you can see that it is a well contrasted image. The difference between white and black, that is noticeable, appreciable difference is there. And that is visible from the histogram also, that all the intensity levels are present in the histogram in the equal amount. ठीक है ना? If you look at this closely, then height of all these is same. So we talk about what is histogram equalization. That is one way to improve the image. And another way to enhance the image is histogram matching. Third one is same thing as, but this is at the local level, not the whole image. When we say that local histogram equalization or local histogram matching, that means a part of the image is being improved, that's all. Rest is okay, but one part was bad, so we are trying to improve that. Otherwise, the whole image is being improved here. When we say in general histogram equalization or HE, then whole image is getting improved. So what is histogram equalization? Let us see. Okay. Now, can you see that there are two diagrams? These are the two diagrams which show the old intensity level of a pixel R versus the new intensity level S. Okay. So old value was R, new value is S, and let us say this is the curve. This is the equation between S and R. So this is one situation. And another situation is this on the right. This is also a relationship between R and S. But the difference between this and this is that here the mapping from R to S, mapping from, this is the set R and K. Okay, this is, let us say R, that is clear. You take anywhere, any RK, correspondingly, you will get XK. But the mapping is not one-to-one. What do we mean by not one-to-one? That there are many R values. As you can see here, there are many R values which are being mapped to one S value. You can see this is horizontal. And corresponding to this horizontal, there is a value SQ. So that means that this pixel, this is being mapped to SQ. This particular pixel, this is also being mapped to SQ, same place. Similarly here, this is also SQ. So there are different pixels which were having different intensities in the image, but finally these pixels, they are going to acquire the same value in the final image. In the right hand side relationship, it is not so. There is one value of R always, and there is one value of K, SK. There is one value of RK, there is one value of SK. Okay, corresponding. So therefore, the difference is that, okay, you will say that still R is being mapped to S. Some values, some input intensity is being mapped to some output intensity, here also, here also. But the difference is that if I say, okay, the S set corresponding to which S, what is the value of what was the value of R? Corresponding, this S is given, you have to find out R. Now in the first case, if I give you this value of S, for other values of S it is okay. But for this particular value of S, what is the value of R, you will tell me. Whether you will tell me this value of R, whether this value of R, whether this, there are many R values corresponding to this. So therefore, when I take the reverse transformation from S to R, then a particular S, I do not know corresponding to which, what is the value of R here. Corresponding to this SQ, what is the value of R, corresponding R here. Whereas in this second case, I know that this is S value, this is corresponding R value, because there is 1-to-1 mapping. Okay. So these type of functions, you can see the first function, you can see that R is increasing, correspondingly S is increasing. Such functions are called monotonically increasing functions. Monotonically increasing functions, that S is increasing, then R is increasing. The word used is monotonically. Whereas second function, which is monotonically increasing, as R is increasing, S is increasing. Apart from that, there is 1-to-1 mapping also, right? So that such functions in mathematics, they are called strictly monotonically increasing. The word used in mathematics is strictly monotonically increasing function. So there is a difference between monotonically increasing and strictly monotonically increasing. Okay. So there's the situation. Now, if such is the situation, just see. If suppose there is a pixel R in the image, and from this image, let us say you are going to change the intensities of the pixel, and this is the new image, this is new image, this is old image. There was a pixel whose value was R, here the value of the intensity is S. Then the probability of, what is the probability of occurrence of this particular intensity level? You know, probability होती है कि how many pixels are there at this intensity level divided by the total pixels in the image. That is called the probability. So PS का meaning है number of pixels at intensity level S, intensity level S divided by M into N. And similarly, PR. PR means what is the probability of occurrence of this particular intensity level R in the input image. So that means number of pixels which are lying at the intensity level R divided by M into N. That will be the similar will be the definition of this fellow. So this PS and PR, they are related to each other because this is a transformation which we have defined. This is a mapping which we have defined. And this mapping, we know what we have defined. This is a mathematical law which we have defined. So therefore, the probability of occurrence of this fellow is related to the probability of occurrence of this fellow. And this is the relation. This is the relation. PS is equal to PR into magnitude of dr by ds. So it is the differentiation of R with respect to S. Now if we take our S, S to be equal to the integration of the values of this image, okay, defined by this equation, you will not able, you will, it is difficult to understand at this level, but we are defining a mathematical law between R and S. We said that this is a mapping. This is a mathematical equation. So let us say this is that mapping. Suppose we are defining this mapping. If we define this mapping, then we can show that your ds by dr is so much. If you differentiate this with respect to r, l minus 1 रह जाएगा, और इंटीग्रेशन का डिफरेंस, इंटीग्रेशन है ना ये पी आर का, भाई ये आर है लिमिट, तो एक तरह से ये पी आर है, पी आर का इंटीग्रेशन है. तो जब तुम डिफरेंशिएट करोगे तो इंटीग्रेशन, डिफरेंशिएशन ऑफ इंटीग्रेशन ऑफ पी आर, तो वो पी आर ही तो रह जाएगा. डी बाई डी आर इंटीग्रेशन पी आर डी आर, दैट विल बी सिंपली पी आर. दिस सॉर्ट ऑफ थिंग आई एम सेइंग. पहले उसका इंटीग्रेशन कर दिया, फिर डिफरेंशिएशन, तो वही तो चीज है, बन गई फिर. सो इफ यू टेक दिस रिलेशनशिप, then we can show that this PS, probability of occurrence of intensity level S, is constant. You need not go into mathematics, but you need to understand this result. Okay? That PS will be a uniform distribution. It's a constant. 1 upon L minus 1. It is independent of the intensity of any pixel. Constant. L जो है 256 है 8 बिट के लिए. समझते हो तुम? नंबर ऑफ इंटेंसिटी लेवल्स. तो इसका मतलब ये हुआ, इफ आई प्लॉट द probability density function of S versus the intensity value S, that will come out to be a constant. This is a constant. 1 upon intensity levels are from 0 to 255. This is 255, and this is the value 1 upon 255. This is the meaning. Initially, in the original image, the probability of occurrence of an intensity value was arbitrary. You can see that this is arbitrary. But after you choose S to be equal to L minus 1 integration 0 to R PW dW, W यहां पर डमी वेरिएबल है, ठीक है ना. इंटीग्रेशन हो जाएगा जब when you put the limits, तो this W की limits you will put, तो W will not remain there, no. This thing will come in terms of R. In fact, this is PR. You are sure that the output probability density function, output का probability density function will come out to be a constant. समझ रहे हो बात को? This is the probability density function of the in the output of the output intensity values. So that means, and we wanted it to be constant. ये तुमने देख लिया था हिस्टोग्राम इक्वल, ये जो हिस्टोग्राम देखा था वेल कंट्रास्टेड इमेज का, you have seen the histogram of well contrasted image. Here this was constant. This probability density function is constant. So therefore we can conclude that if we choose S equal to this, then my histogram, new histogram, अब नई इमेज आ गई ना, तो नई इमेज आ गई तो नया हिस्टोग्राम ड्रॉ कर सकते हैं. तो न्यू हिस्टोग्राम will have the number of pixels at each intensity value. ये number of ये intensity values हैं, and you can say that these are the number of pixels. So at every value, at every intensity value, the number of pixels is same. और इसका मीनिंग ये है कि histogram equalization has been achieved. We say that histogram equalization is achieved. So this is the principle behind histogram equalization, that we try to make the histogram flat, uniform. When your S and R are continuous variables, ठीक है ना. लेकिन in an image which is discrete image, जिसमें intensity values are discrete, 0 to 255, you know that, है ना, and number of pixels is also discrete. But however large they are, but you can count them, na. They are not uncountable. They are countable. ठीक है ना. 512 by 512 की image है, so 512 by 500 we can count. We can find out how much this is, and this is very much a finite number, isn't it? So whenever number of pixels are discrete and intensity values are also discrete, they are not continuous, then we can change the same equation, same law, into this. You can see here, for discrete intensity values, the above relation reduces to same thing. Now, but here I will write a particular intensity value. I mean, discrete है ना, वहां पे तो variable का नाम लिख दिया था. S was the name of the variable which stood for output intensity level of any pixel. But here you have to tell the value also. So Sk is the intensity of a particular pixel, and this is being achieved after some transformation, after some mathematical rule is being applied on the previous intensity value Rk. ये old image में थी, ये old है image. अब आपके पास new intensity values आ रही हैं, and new intensity value कैसे आ रही हैं? By this equation. This is the equation to calculate the new intensity value. L-1 वो वहां पे भी था. In place of integration, what you have is summation. In place of integration, discrete case में integration changes to summation. That's all. So yeah, ठीक है ना. जब तुम्हारा समेशन में कन्वर्ट हो गया तो ये इक्वेशन बन गई. This is the equation for calculating Sk. And what is PRJ? PRJ means probability of occurrence of a pixel at intensity level Rj. Probability of occurrence of this particular intensity level. That means how many pixels are there at intensity level Rj divided by the total number of pixels in the image. That is called probability. Okay, you know what is probability. It's not difficult to imagine. ठीक है ना? So this is called histogram equalization. And histogram equalization, you know, the results are very similar to the contrast stretching curve which we had earlier. Do you remember that we had a contrast stretching curve? MATLAB में मैंने उस दिन तुम्हें दिखाया था. If you remember, 1/1 plus R by something raised to the power E, वो सब किया नहीं था? वो सब किया था, उसको एनकोड भी किया था. तो M into something, wow, I don't know. So that was a contrast stretching curve. So histogram equalization also improves the contrast. Contrast stretching process also improves the contrast. But here we have the advantage of full automation, since histogram equalization automatically determines a transformation function to produce a new image with a uniform histogram. In case of this is contrast stretching, you needed to write this equation. You have to find out the equation, mathematical equation. But in case of histogram equalization, you need only one relation. and you need not, I mean, remember or conclude this equation of this curve. This relation is enough, which is always remaining same for all images. It doesn't change. So what he means is that it is easier to carry out histogram equalization. Okay. So you can just see this is a numerical example. We will not do this numerical example here, but idea is that there was an image. This image was 64 by 64 pixels, and each intensity level was a 3-bit intensity level. 3-bit intensity level means the intensity levels were varying from 0, 0, 0 to, these were the 8 intensity levels. ठीक है ना, 3-bit में क्या हो सकता है, 2⁻3, 101, 110, 111. Okay, so these are the 8 intensity levels which are associated. So this was a 64 by 64 image. This way also 64 pixels. This way 64 pixels, and each intensity was either this or this or this or this or this. Similarly, next pixel, any one of these, that must be the intensity of this, and so on. Each intensity value was one of these. So he says that intensity level 0, अगर इसको डेसिमल में कन्वर्ट करो तो ये डेसिमल वैल्यू इफ आई राइट, so this is 0, this is 1, this is 2, and so on up to this is 7. You know that. So intensity value 0 पे there were 790 pixels in the image. समझ में आ रही है बात? There were 790 pixels. Similarly, at 1, the intensity value 1, so many, like that. I think you understand now. What is this? Level they are given. If you want, you can calculate the probability of occurrence of a particular intensity level. This is the way it is done. By 790 pixels were there at intensity value 0. Black pixel थे 790. Total pixel हो गए 64 by 64. 64 by 64 होता है 4096. You know that. 64 by 64 4096 होता है. ठीक है ना? तो probability कितनी हो गई? 790 by 4096. Similarly, other probabilities. तो probability निकालना तो मुश्किल नहीं है, इजी बात है ना. क्या कोई प्रॉब्लम है? बोल दो, ठीक है ना, बोल दो यार. Probability is easy. और उसके बाद में कोई मुश्किल नहीं है. We have applied this equation Sk equal to L minus 1 summation PRJ. ठीक है ना. ये इक्वेशन मैंने यहां लिख देता हूं, Sk इक्वल टू समेशन, ये L माइनस 1 तो है ही, सॉरी L माइनस 1 यहां पे है, L माइनस 1 समेशन PRJ where J is equal to 0 to K. This was the equation. So let us calculate the new intensity levels. New intensity level S0. By this definition, it will be L minus 1. So there are 8 intensity levels, you know that. Capital L 8 हो गया ना आपका. 3-bit system है, so there are 8 intensity levels. So therefore, L minus 1 or summation PRJ, J varying from 0 to K. K की वैल्यू 0 है. This is K. तो J इक्वल टू 0 से 0 तक वेरी कर रहा है. 0 से 0 तक वेरी कर रहा है, तो दैट मीन्स PR नॉट. J की वैल्यू 0 है, दैट मीन्स. और PR नॉट आपने फाइंड आउट किया था 790 by 0.19 जो था दैट वाज PR0, तो PR0 को 0.19 रख दिया, 0.19, तो आपका 1.33 आ गया। इसी तरह से S1 में क्या करेंगे, J विल बी फ्रॉम 0 to 1, J इक्वल टू 0 to K होता है ना, तो K आपका 1 हो गया, K इज 1, तो दैट मीन्स PR0 प्लस PR1। अब समेशन में दो टर्म्स आ जाएंगी, देखो PR0 एंड PR1। PR0 0.19 है, PR1 0.25 है, ये PR1 है, ये PR2 है, एंड सो ऑन, ये PR7 है, R7। तो इस तरह से ये कैलकुलेट हो गया। ऐसे ही बस कैलकुलेट करते चले गए, S2, S3, S4, S5, S6, S7, ये न्यू इंटेंसिटी लेवल्स आ गए। और जब न्यू इंटेंसिटी लेवल्स आ गए तो यू नो दैट द इंटेंसिटी लेवल्स आर ऑलवेज इंटीजर, सो इनको राउंडिंग कर दिया, क्योंकि ये तो रियल नंबर आएंगे ना, ये तो मैथमेटिक्स चल रही है, तो मैथमेटिक्स में तो रियल नंबर आएंगे। बट दिस इंटेंसिटी लेवल 4.55 एक्चुअली कैन नॉट एग्जिस्ट, इसको इस 5 इंटेंसिटी लेवल एक्चुअली 5 होगा कॉरस्पॉन्डिंग टू दिस। इसी तरह से 5.67 इंटेंसिटी लेवल कैन नॉट बी देयर इन एन इमेज, सो दैट मीन्स इट विल बी 6, राउंड ऑफ कर दो, सो दैट वे S0 इक्वल टू 1, ये तुम्हारे राउंड ऑफ करने के बाद में ये S4, S5, ये सब आ गए अप टू S7। उसमें से फॉर एग्जांपल S5 एंड S6 एंड S7 दे आर सेम, तीनों की वैल्यू 7 है। इसी तरह से S3 और S4 दोनों की वैल्यू 6 है, एंड दीज वर डिफरेंट, ये 1 है, ये 3 है, ये 5 है, ये दोनों 6 हैं, ये तीनों 7 है। So that means now you know that in the new image no pixel is occupying the, let us say, intensity level 2। देखो S0 1 है, S1 3 है, इसका मतलब intensity level 2 जो है that is not being occupied by any pixel। Similarly intensity level 4 no pixel is at intensity level 4, लेकिन इंटेंसिटी लेवल 5 पे है पिक्सल, इंटेंसिटी लेवल 6 पे पिक्सल है, इंटेंसिटी लेवल 7 पे पिक्सल है, ठीक है ना। तो कहने का मतलब ये है कि अब सिचुएशन ये हो गई कि दीज वर द ओल्ड इंटेंसिटी वैल्यूज, ओल्ड, ये जो है ना, दीज आर द ओल्ड इंटेंसिटी वैल्यूज, इनके कॉरस्पॉन्डिंग तुमने ये न्यू इंटेंसिटी वैल्यूज निकालनी, न्यू, और पिक्सेल्स, नंबर ऑफ पिक्सल तो गिवन है। देखो फॉर एग्जांपल R0 इक्वल टू 0 के कॉरस्पॉन्डिंग 790 थे, तो इसका मतलब S0 इक्वल टू 1 हो गया ना, R0 इक्वल टू 0 नहीं, अब 0 लेवल भी खत्म हो गया। देखो S0 पहला इंटेंसिटी वैल्यू 1 आया, 0 नहीं है, तो दैट मींस एट इंटेंसिटी वैल्यू 0 देयर इज नो पिक्सल इन द इमेज, 2 पे भी नहीं है, 4 पे भी नहीं है, 0 पे भी नहीं है। So that means corresponding to this R0 there were 790 पिक्सल। now वो 790 पिक्सल इंटेंसिटी 1 ऑक्यूपाई कर रहे हैं, इंटेंसिटी लेवल 1 ऑक्यूपाई कर रहे हैं। इस तरह से ये हो गया, इसी तरह से ये हो गया। अच्छा, there are two old levels 3 and 4 which have gone to intensity level 6, तो उनका प्रोबेबिलिटी करने के लिए क्या करेंगे, हाउ मेनी ऑफ देम आर इंटेंसिटी लेवल 3, हाउ मेनी ऑफ देम आर इंटेंसिटी लेवल 4, उन दोनों का समेशन कर दिया, तो ये आ गया। तो टोटल नंबर ऑफ पिक्सल इस 6 लेवल पे है, 985 पिक्सल 6 लेवल पे पहुंच गए। इसी तरह से ओल्ड लेवल 5, 6, 7 पे जो पिक्सल थे 245, 122 और 81, ये गिवन है पहले से। देखो ये लास्ट की वैल्यू 245, 122, 81। Now then, they are no longer at this, वो अब 7 लेवल पे पहुंच गए। अब वो 5, 6, 7 पे जो थे वो सारे 7 पे चले गए. So that means 448 pixels are now occupying the level, intensity level 7. समझ रहे हो ना, या कोई प्रॉब्लम हो रही है बताओ? I am calculating the new intensity values and the how many pixels are there at those intensity values, new intensity values. वो कैलकुलेट कर रहा हूं यार मैं. और प्रोबेबिलिटी में तो कोई दिक्कत नहीं है, 4096 से डिवाइड कर दूंगा मैं हर चीज को. जो ये नंबर्स आए 4096 तो प्रोबेबिलिटी आ जाएगी. तो अब अगर तुम देखो ध्यान से, 0 वैल्यू पे कोई पिक्सल नहीं है, 2 पे भी कोई नहीं है, 4 पे भी कोई नहीं है, 1 पे दिस इज द प्रोबेबिलिटी 0.19 आ गई देखो. 3 के कॉरस्पॉन्डिंग 0.25 ये वाली, 5 के कॉरस्पॉन्डिंग 0.21 ये वाली, ठीक है ना. देन ये वाली 0.24 ये रही, एंड लेट अस से ये वाली वैल्यू ये रही. बोलो, पहले 8 लेवल्स थे, नाउ ओनली 5 लेवल्स आर देयर इन द न्यू इमेज. 3 लेवल्स पे देयर इज नो पिक्सल. तो दिस वाज द ओल्ड वन, ये पुराना हिस्टोग्राम है corresponding to this. New histogram is corresponding to this. अब तुम देखो इस हिस्टोग्राम को, this is almost uniform distribution. All the probability values are near this, nearly this. कोई थोड़ी सा ज्यादा है, कोई कम, nearly this. पुराने वाले में देखो क्या वेरिएशन चल रहा है, कोई नियरली कह नहीं सकते. देयर वाज नो एवरेज लेवल. लॉट ऑफ वेरिएशन वाज देयर इन द प्रोबेबिलिटी वैल्यूज. नाउ ऑल द प्रोबेबिलिटी वैल्यूज आर नियरली सेम. Same. And you know what, so much difference, you will say that where they are same, there is so much of difference still. 0.25 है, ये 0.11 है. देखो, this was an example of only 64 by 64 image, very small, only 8 intensity levels. Practically, ठीक है ना, कोई भी ग्रे स्केल इमेज होगी, that will be appreciable size, मतलब जिनके लिए वैलिड है, ठीक है ना. हिस्टोग्राम इक्वलाइजेशन जो वैलिड है वो इतनी छोटी इमेजेस के लिए नहीं है. बेसिकली हियर यू कुड डू द कैलकुलेशन मैनुअली बाय योर हैंड. इट वाज सच ए स्मॉल एग्जांपल, दैट्स व्हाई द रिजल्ट इज like this, as if there is lot of variation still in the probability values. But when you take a large image, ठीक है ना, देखो प्रोबेबिलिटी का तो फंडा ही है. मैथमेटिक्स में जब तुम प्रोबेबिलिटी स्टडी करते हो, व्हाट इज द फंडा? कि प्रोबेबिलिटी इज डिफाइंड टू बी समथिंग व्हेन द नंबर ऑफ ट्रायल्स, नंबर ऑफ थिंग्स इज लार्ज. है कि नहीं? आता है वन टाइम देयर, तुमने 5 टाइम्स यू हैव टॉस्ड ए कॉइन, तो क्या हेड आने की प्रोबेबिलिटी जो है, प्रोबेबिलिटी ऑफ अकरेंस ऑफ हेड, क्या 4/5 हो जाती है? या प्रोबेबिलिटी ऑफ अकरेंस ऑफ टेल क्या 1/5 है? नो, इट्स नॉट. इट्स नॉट, बिकॉज द वेरी assumption that probability is defined only when number of trials tends towards infinity. अगर तुम 1 लाख टाइम्स ट्रायल करो तो मैं मान लूंगा कि 1 लाख में से व्हाटएवर, ये क्या है, क्या लिख दिया मैंने, जो भी है, ठीक है ना. इफ सपोज वी डू 1 लाख ट्रायल्स, उसमें से तुम कह सकते हो कि भाई 49,500 टाइम्स जो था हेड आया और 50,500 टाइम्स जो है वो टेल आया. तो दैट मीन्स तब मैं मान लूंगा कि हेड आने की प्रोबेबिलिटी जो है दैट इज इक्वल टू 49,500 डिवाइडेड बाय 1 लाख. ठीक है ना, ऑलमोस्ट 0.5, ऑलमोस्ट मतलब 0.495. चलो, क्योंकि still so far as the number of trials you can count, अगर आप काउंट कर सकते हो नंबर ऑफ ट्रायल्स को, इसका मतलब आपकी प्रोबेबिलिटी की डेफिनेशन वहां पे अप्लाई ही नहीं होती। प्रोबेबिलिटी अनकाउंटेबल चीजों पे अप्लाई होती है, ठीक है ना। तो ये बात ध्यान रखना। तो यहां पर तो इमेज बेचारी छोटी सी इमेज, तो यही होना था यहाँ पे। नंबर ऑफ पिक्सेल्स इज ऑल्सो स्मॉल, नंबर ऑफ इंटेंसिटी लेवल्स इज ऑल्सो 8 ओनली। 256 इंटेंसिटी लेवल रखो तब देखना हिस्टोग्राम क्या होता है, हिस्टोग्राम इक्वलाइजेशन, ठीक है ना। तो ये मतलब है। तो नाउ यू हैव अंडरस्टूड एट लीस्ट द सोल ऑफ इट, दैट व्हाट इज हिस्टोग्राम इक्वलाइजेशन। All intensity levels are having almost same probability of occurrence. That is called histogram equalization. And for that, this is the law which is to be applied. This is the so that is equal to L minus 1 into the summation of the pixel probability from 0 to 0. इसकी डेफिनेशन में क्या आ रहा है? L minus 1 आ रहा है। In this image, L minus 1 which I showed you, moon image, there L minus 1 is 255. समझते हो? There are 256 levels. That is a normal image. That example is not a fabricated example. This was a fabricated example just to show you the histogram equalization principle. ये probability of R naught. What is R naught? R naught means zero intensity level की क्या probability है? See, so many pixels are lying at zero intensity level. ये सारे pixels जो है ना, they are black. Are you understanding what I am saying? ये black लग रहे हैं तुमको? There are many pixels which are black. So therefore, the number of pixels of black having black level, that is high, very high in this image. And due to that, the probability of occurrence of the क्या नाम है zero intensity level, that is very high. Very high. Probability of occurrence of zero intensity level is very high. और इसलिए हमने जब S नॉट कैलकुलेट किया तो वो आया 255 मल्टीप्लाइड बाय पी आर नॉट बाय डेफिनेशन. This पी आर नॉट इज वेरी हाई. 255 is also a high number. So therefore S naught is very high. S naught is very high. So that means वही प्रॉब्लम है. अगर तुम फाइनल हिस्टोग्राम आफ्टर हिस्टोग्राम इक्वलाइजेशन इफ यू लुक एट द इमेज तो S नॉट की वैल्यू यहां लाई कर रही है. दिस इज S नॉट. पहला इंटेंसिटी लेवल यहां आया है. दिस इज द वेरी फर्स्ट इंटेंसिटी लेवल दैट वी हैव अचीव्ड. इट इज रिटन हियर 255. ये PR नॉट इज ऑलमोस्ट 0.9. 90% पिक्सेल्स जो है वो जीरो इंटेंसिटी पे हैं. सो इसका मतलब क्या हुआ? इसका मीनिंग ये हुआ कि द वेरी फर्स्ट इंटेंसिटी लेवल which was which is existing in the new image, that intensity level itself is very high. It is visible. And after that, okay, after that things are okay. But what about the area which is here to here? No pixel is having intensity level less than, let us say, 140. If this is 140, so no pixel is having the value of intensity less than 140. And that is being seen in the image also.